Discover how vectors and dot products measure similarity between directions. Two vectors pointing in different directions. How do we measure how similar they are? Let's start with the basics of what vectors are. A vector is a mathematical object that has both magnitude, which is its length, and direction, which is where it points. We can represent a vector using its x and y components, showing how far it goes in each direction. We write a vector v as a column of numbers representing its components. For example, this vector a equals 2 in the x direction and 1 in the y direction. Now let's explore how we measure similarity between vectors. Two vectors are considered similar when they point in the same or nearly the same direction. These two vectors are similar because they point in nearly the same direction. These vectors are not similar because they point in very different directions. The dot product is the mathematical tool we use to measure this similarity. The dot product of two vectors equals the product of their x components plus the product of their y components. Let's calculate an actual dot product with specific numbers. We have vector a equals 3, 4, and vector b equals 2, 1. The dot product equals 3 times 2 plus 4 times 1, which gives us 6 plus 4 equals 10. The dot product has a beautiful geometric interpretation using angles. The dot product also equals the magnitude of a times the magnitude of b times the cosine of the angle between them. The angle theta between the vectors determines how similar they are. When the angle is 0 degrees, the vectors point in exactly the same direction and the dot product is maximized. When the angle is 90 degrees, the vectors are perpendicular and the dot product equals 0. When the angle is 180 degrees, the vectors point in opposite directions and the dot product is negative. Let's understand what different dot product values tell us about similarity. A positive dot product means similar directions, 0 means perpendicular, and negative means opposite directions. When the dot product is positive, the vectors are similar and point in roughly the same direction. When the dot product is 0, the vectors are perpendicular and completely unrelated. When the dot product is negative, the vectors point in opposite directions. Let's see a concrete example with actual numbers. Consider two vectors, u equals 3, 4 and versus equals 4, 3. Their dot product is 3 times 4 plus 4 times 3, which equals 24. Since 24 is positive and relatively large, these vectors are very similar in direction. The magnitude of u is the square root of 3 squared plus 4 squared, which equals 5. The magnitude of b is also 5. Using our formula, cosine of theta equals 24 divided by 25, which is 0.96. This gives us an angle of about 16.3 degrees, confirming these vectors are very similar. Dot products have many important applications in mathematics and computer science. In machine learning, dot products measure similarity between data points, helping algorithms classify and cluster information. In computer graphics, dot products determine how light reflects off surfaces for realistic rendering. In physics, the dot product calculates the work done when a force moves an object. Recommendation systems use dot products to find items similar to what you like. Let's recap what we've learned about vectors and dot products. Vectors are mathematical objects with both magnitude and direction. The dot product gives us a numerical measure of how similar two vectors are. A positive dot product indicates vectors pointing in similar directions. The dot product is directly related to the cosine of the angle between vectors. This simple concept powers applications across science, engineering, and artificial intelligence.